Hello students, today I will be conducting a demonstration to introduce today's lesson. Your job is to record data when prompted as well as note any observations that you make. So as can be seen here, I have a ramp set up and my job is to line up the ball at the top and release it. Why is it important that when I perform this demonstration, I just release the ball down the ramp and not push it? Yes, Ashton?
I think if you were to push the ball down the ramp, it wouldn't be accurate data because you're giving it force, I guess, rather than just letting it naturally fall down.
All right, explain your thinking.
Well, if you were to push the ball with a force acting on it, that force is not what we're measuring. So the data that you would get wouldn't accurately show what you're trying to measure.
What tools can we use to measure the distance the ball travels? Yes, Maddie?
You could use a yardstick.
What else? Alexa?
A measuring tape.
Ashton?
I think you could also use something that's not traditional measurements. You could use someone's feet or shoes, or you could use standard objects that stay the same.
Awesome. Yeah, so for the purposes of today's lesson, we're going to use the non-standard measurement of steps. Before we get into the demonstration, I'd like to go over our expectations for the lesson. So while I perform 3 trials, your job is to record the distance the ball travels as well as any observations you make. So how many trials are we conducting?
3.
3. And what are we recording on our data sheet? Are your hands raised? Sorry, Ashton.
The distance that the ball's going to travel.
Awesome. So for this first round, hold on, I need to set y'all down. For this first, well, y'all can see it. For this first round, I'm going to adjust our ramp so that we only have 1 block instead of 3 blocks, which I currently have. So to show y'all see the 1 block right here with the ramp on it. I'm gonna show the iPad. 1 block. Okay. What should I keep in mind as I make these adjustments to the ramp? Maddie?
To not change other factors. If you're changing ramp height, that should be the only change that you make.
All right, tell me why it's important not to change any factor other than height. Alexa?
Because if you change the other factors, it'll make all of the data wouldn't make sense. It'd be all inaccurate.
Right. All right, so I have the ball. I'm gonna line it up at the very top and, wait, hold on. I'm gonna get y'all so y'all can see. Okay, I have the ball lined up at the top. Whoa. And I'm gonna release it. Okay. And I'm going to use the non-standard measurement of steps. So I'm gonna start at the very bottom of the ramp. I'm not gonna show you my feet because it's awkward. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'd say that's pretty much in line. So, get your writing utensil and your notes, and I want you to record 14 steps for our first measurement and any observations that you made about that. All right, now I'm gonna take another block and I'm gonna add it to my ramp. So instead of 1 block, I have 2. Let's see. And then same thing, I'm going to line up the ball at the top of the ramp and release it, not push it. Let's see. You can start counting. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, and it's actually rolled over the couch. But is that 34? Oh my goodness. Okay, so 34. Get your writing utensil and your notes again and mark 34 for our second round. Before we move on to the third round, what do you notice about this round that is different from the first round? Maddie?
The ball traveled farther the second time than it did the first time.
How do you know this?
With distance, the bigger the number measures, the greater the distance. So since the number measured for this round is higher than the first round, we know that the ball traveled further this time.
All right, so for our third and final round, I'm adding the third block to the ramp, getting that lined up. And then one more time, I'm going to line it up at the very top, being careful to just release it, not push it. And I'm gonna go ahead and start counting because it takes a minute. So 1, 2, I'm actually gonna redo that one because it hit an outside object, which what did we talk about that does? If we change other factors.
Inaccurate data.
Exactly, so that's gonna skew our data, so we're gonna do a retry for our third trial. So release it, not push it. Start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, oh my goodness, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. So for our third round, get your writing utensil and your notes and write 39 for our data. And any observations you made about that third round and how it compares to the second and the first round. How do you think the angle of the ramp affects the speed and distance traveled by the ball? Ashton?
I think that if the ramp was higher, like in the second and third rounds, it increased the rate and the distance, so it gains more momentum and then goes further.
All right, and what factors other than the ramp height do you think could influence the behavior of the ball? Alexa?
The density of the ball, like how heavy it will be.
Maddie?
Maybe like the material of the ball, like what it's made out of, that could make a difference.
Ashton?
I also think the friction, so like, for instance, if you did it on a different surface other than like the wood, like if you did it on carpet or if you did it on like a different type of floor, it may influence like the friction.
All right, and tell me how you know each of these things you listed will influence the ball's behavior. Ashton?
I think that any factor in general just has the ability to have an influence on like the behavior of the ball, but I think the ones we specifically mentioned have the most like direct influence of how far the ball traveled.
All right, thank you. That's it.